All right, so one of the big ideas here is greatest common factor. And that's when we compare two or more numbers for common divisibility. Sometimes it's called greatest common divisor. And we'll see it abbreviated GCF or GCD. And let's just pick on a couple of easy numbers like 12 and 18. So the most basic way to come up with the greatest common factor is to list all factors, find the common ones, and then look for the greatest of them. So it's kind of a 1, 2, 3 step in reverse of the name of it. So to find all factors of a number, that's when we think about rectangles. How could I make a rectangle out of 12 squares? I could make it 1 by 12, or I could make it 2 by 6, or I could make it 3 by 4. And when I start thinking about 4, I realize I already have it and I'm done. 18, I could make a rectangle that is 1 by 18, or 2 by 9, or 3 by 6. 4 doesn't work, 5 doesn't work, and there's 6, so I'm done. For common factors, we have a 1 and a 2 and a 3, and not a 4, but a 6, and that's all we get. So we have factors, we have common factors. The greatest common factor of 12 and 18 seems to be 6, according to this list here. So that's the most common way. That's the way kids are generally introduced to it, to figure out a way to list the factors and find the biggest one they have in common. Another way to do it is with prime factorizations. So this is what we call the list method. So then instead of making a list of all factors, I make a factor tree. 2 goes into 12 6 times, 2 goes into 6 3 times. So 12 is equal to 2 times 2 times 3, which we often abbreviate by saying that's 2 squared times 3. 18 would be 2 goes in 9 times, and 3 goes into 9 because 2 doesn't, 3 times, and I'm done. So then I have 18 goes in, let's see, it's 2 times 3 squared. And then from those prime factorizations, I'm going to build the greatest common factor. Now, again, I'm looking for factors that they have in common, and here I can see they have 2's in common and they have 3's in common. Now, 12 has 2 2's, but 18 only has 1 of them, so they only have 1 2 in common. 12 has a single 3, 18 has 2 of them, so they only have a single 3 in common. And so the process, the shortcut here, 2 times 3 is 6 for the greatest common factor, is what I'm looking for is the lowest power of the common primes. We'll play with that with other example. So lowest power of common primes. So we have the list method, we have the prime factorization method. Prime factorization method is basically that idea right there. The list method, again, is looking for factors that are common and then pick the greatest. Another method is Euclid's method. And Euclid's method involves repeated division to figure out what the common factor is. So with 12 and 18, what I do is I take the 18 and I divide by 12. 12 goes into 18 one time with a remainder of 6. Then I move 12 up to be the dividend, and I take the remainder and make it the divisor. 6 goes into 12 two times with a remainder of 0. And sometimes it takes more than 2 steps, but once you hit that remainder of 0, the previous remainder has to be the greatest common factor. And 0 tells us when to look back and get that. So 0 is that flag that says, yo, that's good right there. So those are our 3 methods for coming up with the greatest common divisor. Now we just need to practice them. Let's do one more example on Euclid because it takes a little getting used to. Let's try finding the greatest common factor of 6 and 35. So again, we have 3 different methods. I'm going to go for Euclid's method. So I'm going to take the 35 first and divide it by 6. So let's see, 6 goes into 30 or 36. So I'm going to have to say 6 goes into 35 5 times. And that's going to give me a remainder of 5. Then I move the 6 up. And this remainder is what moves into the divisor position. Again, I take the 6 and move that up. And the remainder and move that up. Coincidentally, the quotient and remainder are the same number here. Obviously, it doesn't happen all the time. Didn't up above. All right, so 5 goes into 6 one time with a remainder of 1. Not a 0, so I keep going. I move the 5 up, take this 1 here, because it's the remainder. 1 goes into 5 times with a remainder of 0. I finally get the 0, and then the last remainder has to be the greatest common factor, 1. So a side note on this, whenever 2 numbers have a greatest common factor of 1, which is kind of boring, that's not really, 1 is not an interesting factor or multiple, these 2 numbers are said to be relatively prime. So the idea of having a greatest common factor equal to 1 means the 2 numbers are relatively prime. They have no interesting common factors. Right, so I would say 6 and 35 are relatively prime. 12 and 18 are not relatively prime because their greatest common factor was 6. So we have the idea of a prime number, and then 2 numbers can be relatively prime if they have no interesting common factors. 1 isn't that interesting.